Hi. So today we'll talk about digestive system. So basically, a digestive system absorbs three main things and digests three main things: carbs, protein, and fat. And what it does, it's too big for it to break down, so it breaks down into smaller pieces. That way, it can be able to absorb more of it. Because the smaller the things are, the more absorption there is, meaning surface area, because they're really tiny. And then to speed up the reaction and what breaks down are enzymes. So basically, for carbohydrates, the macronutrient is polysaccharides such as glycogen and starch. And then it's breaking down into sucrose, maltose, and lactose, which are disaccharides, through amylase. And then sucrose, maltose, and lactose are broken down into glucose through maltase, sucrase, lactase. So basically, the glycogen is the macronutrient, and the glucose is the monomer. And then we have protein. So the macronutrient for protein is protein, and then that's breaking down into polypeptide through pepsin, and then polypeptide is breaking down into dipeptide through trypsin, and then dipeptide is breaking down into amino acid through peptidase. And then last we have fat, so it basically starts off as lipids that's breaking down into fatty acid through lipase. Oh, my bad. Oh. Now we'll get on to the structures. So the first structure is the esophagus. And the esophagus is a long muscular tube that connects mouth towards stomach. And it basically has muscle-like contractions to push the food toward the stomach. And that process is called peristalsis. So yeah, the process of pushing the muscle-like contractions pushing food towards stomach is called peristalsis. And then next we have the liver and gallbladder. So the liver, it emulsifies, meaning it breaks down big blobs into small droplets of fat, so they don't come in contact with water, since it's bad. And the gallbladder stores the bile and then releases to the duodenum, so it can break down and absorb the fat. So basically, liver emulsify fat, so it doesn't make contact with water, and then the gallbladder stores the bile and releases the duodenum so it can break down and absorb fat. Next we have the pancreas. So the pancreas basically, it neutralizes the chyme, which is food plus acid plus water, it basically releases sodium bicarbonate to neutralize the chyme, which is food plus acid plus water, as it comes down to the duodenum, since the duodenum cannot handle very acidic things. And then the pancreas also releases enzymes to break down intermediates to monomers. So, and also, after you eat, your pancreas would release insulin to lower the blood sugars, and then while you're not eating, your pancreas would release glucagon to increase the blood sugar. And then next we have the jejunum and ileum. So the ileum is longer than the jejunum. Yeah, so the ileum is longer than the jejunum, and they both also have villi, and inside the villi they have macrovilli to increase surface area because they're basically tiny blood vessels. So basically, the carbs and protein monomers goes into the microvilli, which is a tiny blood vessels, in order for them to be absorbed. And then they also have lactate, and that is where the fatty acid goes into, which is the monomer. No, the lipids go to, which is the monomer of fat, into for absorption. So basically, the ileum is shorter than the jejunum, and they both have macrovilli and side villi, which are tiny blood vessels to increase surface area for the protein and carb monomers to go inside and through, and for it to be absorbed. And then they also have lactate, which is where the lipid goes through. Oh yeah, also, microvilli has capillary bed, which is the tiny blood vessels. And then now we have the duodenum. So the duodenum is the first and shortest part of the small intestine, and it's also the main site of chemical digestion. So without the duodenum, then you can't really get protein and carbs and stuff. Because the duodenum breaks down the protein and carbs intermediates into monomers through the enzymes that the pancreas gives them. So yeah, it's basically the first and shortest part of the small intestine, and it also breaks down the protein, carbs, intermediates into monomers, and it's the main site of chemical digestion. Now we have stomach. So the stomach is very acidic. To activate enzymes so they can work and cut down protein. And then they mixes that food with acid and enzymes, which becomes chyme, which I mentioned earlier. And then it goes to the small intestine in order to absorb the nutrients. So basically, so far, it's very confusing. But basically, the stomach is super duper acidic, very acidic, so it can release the enzymes for things to be broken down and digested, and then it also mixes food with water and acid and enzymes. No, sorry, food plus acid. It's chyme is food and acids and enzymes. So it makes chyme with food plus acid plus enzymes to be sent to the duodenum. That way it can be digested and absorbed. So yeah, and then there's also mucus in the stomach to prevent acid damage to the stomach's walls, and it also releases pepsinogen, which hydrogen chloride activates the pepsinogen to save pepsine, so the pepsine wouldn't digest the stomach's lining, which is made out of protein. So basically, it releases hydrogen chloride to change the pepsinogen into safe peps. Bleh. So basically, it releases pepsinogen, which hydrogen chloride activates to be so basically it releases pepsinogen, so the hydrogen chloride can mix with that to okay, so basically it releases pepsinogen to activate. So basically it releases pepsinogen, and then the hydrogen chloride activates that pepsinogen into safe pepsine. That way it can safely digest protein, so it doesn't digest the stomach's wall lining, which is made out of protein. Yes. So it releases pepsinogen to activate, so the hydrogen chloride can activate that into safe pepsine so it doesn't absorb or digest the stomach's lining, which is made out of protein. And there's also mucus in it, so there's also no damage to the lining. And then also the stomach, there's the food mixes with enzymes and acid to become chyme. That way it's sent to the duodenum, and it's also very acidic to activate enzymes to cut down and work protein, because protein is really difficult. So basically, it's very acidic to activate enzymes to cut down protein. Mucus in stomach to prevent damage to stomach's lining wall. Releases pepsinogen, which hydrogen chloride activates that into safe pepsin. That way it does not damage then the the stomach's lining wall, which is made out of protein.